Question 6. So state, which means this shouldn't involve too much, the values of A and B. So it doesn't involve too much, but it does involve quite a lot of understanding. So we have this, and I know that A is the amplitude, and that A here is the amplitude, and B is the period. So I'm going to start with the amplitude, which is A. So what is the amplitude? So the amplitude, the formula, some people can just read it off the graph, but if you can't, that's okay. This is a good way to check. Amplitude is equal to the maximum minus the minimum all divided by 2. So our maximum is here is 5, and our minimum is -5. You can just read that off the graph. So 5, if we're negativing a negative, subtracting a negative, that's positive. So it's 5 plus 5 over 2, which I know is 5. So that's our value of 5. And then that applies, that's a general formula that you can use for anything, because not all cosine graphs are going to be nice like this. Because for instance, if you shifted that graph up by something on the y-axis, you know, this, say we shifted it up by 3, then this would be 8, and then this would be -2. So then how would you find amplitude then? Well, you still might be able to see it, but this formula, if used here, would give you the same answer. So that's where that comes from. And then looking for our value of B, well, B is the period of the graph. So what is the period? Basically how many degrees it takes up on the x-axis. So I know that one normal cosine graph, I'm going to draw here like that, takes 360 degrees. But oh look, we have multiple, you can think of them as miniature cosine graphs. We have 2 of them within 180 degrees. So then you would do 180 divided by 2 is equal to 90 degrees. So each of these cosine graphs takes 90 degrees, not the normal 360. So then you ask yourself the question, well, how many of these miniature cosines can I fit in one big cosine? Well, that'd be 360 divided by 90, which is 4. So the value of B is 4, because B is asking you how many miniature cosines can we fit in one normal one, and that's your answer. Hope that helped.